Now let's talk about XTS plotting and what are called ACF functions. First, I'm going to create a random time series, and we're going to explore the lagged values. Now, when we plot a time series object, it looks different from a basic data matrix plot. Here we can see grid lines and timestamps on the x-axis. So let's revisit the lagged values. I'm going to c-bind x with a lagged version of itself. A great way to see the relationship between these lagged and current values is to use lag.plot. Now this looks messy, and it's mostly because we have been using random data, but it shows you the differences between current and lagged values and how they evolve. Let's see how it looks when we use a cumulative sum of the series. I forgot an m in the cumulative sum function. So here is the cumulative series. Now let's see what a lag plot looks like on this cumulative series. Now we see more of a developing pattern. We can see that from each observation to the next, there's a general trend upwards, just as we saw in the plot of the series. Around the 15th observation, it starts to turn back and turn downwards. Another important plot when analyzing time series data is called the autocorrelation function. This will give you a plot of the correlation at every available lag in the time series. So let's create a new random series that's a little longer than our last one. To see the ACF plot, it's very simple. Just use the ACF function. Now this plot tells us if there are correlations among the lags. Usually when we are creating a time series model, such as an ARIMA model, we want to select the number of lags that cause all of the lag correlations to drop below the blue threshold. Now the lag correlations are all below 20%, which is a good indication that there is no autocorrelation in this series. Now, of course, you'll notice that the 0th lag is 1. That's because the series is perfectly correlated with itself. Now, what if we use the ACF function on the cumulative series of that random data set? Now we can see a concerning pattern. There is strong autocorrelation. And this makes sense because each observation now contains all of the previous observations, which increases the lag correlations. Now, this heavy linear dependence can be seen as a spike in the first lag of what's called a partial autocorrelation function. To look at that plot, just use PACF. In this lesson, I introduced you to a few new plotting tools that are useful when analyzing time series data.